and its usage can be done in the field of agrometallurgy. I think now my screen is shared. Just a minute. Okay. So now you can see my screen.
Not yet.
Not yet. Now? No. Just a minute. What happened? I think this screen now is coming. Show my screen anyway. Now it's coming. I think it's coming now. Now? Now? Yes. Yeah. Fine. So I welcome you all. I hope that you will understand that at present the remote sensing and GIS is playing a very important role, not only field of agriculture meteorology in every part, whether it's a geology, whether it's a hydrology, everything. Because finally, if you want to run any type of model or any site of process, you need data. So only point data cannot satisfy the all needs. So we are working in a space application center ISRO Ahmedabad, where we are trying to address not only agriculture meteorology, but different sectors of agriculture, dairy, pest and disease, irrigation, water stress, plantation, soil, horticulture, and field crops. So we are working in a big umbrella, and we have a team who are addressing all these things. And basis of our study, we are planning to introduce new sensor definition also. What ISRO going to be launched in future for Earth observation in the field of agriculture, that we will decide on the basis of our research, our understanding. So before jumping to our topic, I just want to introduce that what is ISRO. So ISRO is an amalgamation of multiple centers, and different centers have different themes. For example, SAC you are saying, so SAC is basically responsible for making payloads in microwave and optical, as well as the antennas and transponder for communication satellites. Similarly, we have URSC also, which is working on only the integration of satellite. And VSSC and LPSC all are working for rocketry part. So different center had different type of mandates. And this is our beautiful campus. We are located in Ahmedabad since 1967. And along with that, we have one center in Delhi also. Whereas in Ahmedabad, we have a multiple center. At present, I am sitting in the main center, which the thing used the building, and we established in 1967. Whereas we have a Bhopal campus also, which is 10 kilometers from our main campus, and few other centers also, which are basically working as a clean rooms. So we have in this particular center the Asia's biggest clean room, where we can do the integration of payloads. So major activities our centers do regarding, I told you, communication, transponders, navigation, like NAVIC, then Earth observation, optical and microwave. These are where the engineers and hardware people are involved. So we have near about 1875 people in this campus or in center, and maximum people involved in the design and development of payloads. Whereas near about 170 persons are involved in applications also, regarding natural resources, meteorology, oceanography, telemedicine, village resource centers, disasters, and many other things. And also we involved in some United Nations-based program also in different mode. So I will start my lecture as per the mandate given to me regarding fundamental or remote sensing. So in this, you just see this picture. So this is, you just see a picture because you cannot elaborate many things. So best sensor what we have in this world is your eyes, because it already you given you the processing unit. Okay. So this is the important thing. So when we take any picture, what we will do? We will try to assess what it want to convey. For example, in this picture, we can write thousands of words about this particular picture, which is showcasing the ice cream. Similarly, in remote sensing, one word is working on thematic ways, on the basis of picture, and one is qualitative and one is quantitative. So we here are working on both aspects, quantitative and qualitative both. So visual interpretation we can do. As I told you, the best sensor is your eyes, and platform is your brain. So when you see any type of things like in green papaya to yellow papaya, your eyes will only capturing the data, but interpretation is going on your brain. Similarly, very same way the remote sensing and satellite world will work. So we have to develop some sensor, we have to develop some platforms, and we have to develop some processing chain which can be used to get the data. So how the satellite work? And if you see the satellite are those anything satellite, moon is also a satellite, around the gravitational force of central mass. And when we use moving this satellite around the globe, around the Earth, centripetal and centrifugal force basically balance it in microgravity because gravity is not going to be zero. So after some long time, satellite have to drift towards Earth. So every time some motor has been fired to put the again the satellite in that particular height and orbit. So if you see, all things are governed by Kepler's law. So the line joining to the planet to sun sweep, as you see in the left hand side, equal area in equal time. So as the sun, in an elliptical mode, Earth is moving. So according to that, we have to train our satellite to have that particular velocity. So we, in general, we have two types of satellites: geosynchronous satellites and sun synchronous satellites. So geosynchronous satellites is working near 35,000 kilometers from the Earth's surface. But what we will do, we'll make the angular velocity of satellite same as the angular velocity of the Earth. So it will focus on a particular place. For example, we are focusing from India from inside satellites. But sun synchronous satellites have a pole to pole. So one satellite can have ability, according to its swath, can move from pole to pole 10 to 12 times, sometimes 14 to 16 times also. And its height is varying from 1600 to 800 kilometers. What polar satellites have advantage? They will give you more high resolution data because they are near to Earth. Whereas geosynchronous satellite have an advantage, it will give you high temporal data. So from INSET or any geosynchronous satellite, every 15 minutes, half an hour, you get the data. But sun synchronous satellites have the ability to give you data in a day, I mean in a 3 day, so in a 5 day, sometimes 16 days. So its repeatedity is less. Whereas geosynchronous satellite is very fast. It has a synoptic coverage every half an hour or 15 minutes. So in case of cyclone and all, the geosynchronous satellites are very helpful. But if you want to assess the intensity, where is the eye of the this cyclone is there, then sun synchronous satellite or polar satellites are helpful. So what type of sensor and type of scanning will do? So if you see in the background when we started SAT or ISRO, we have a Bhaskar camera. So area by area capture will do. That is a very old process. Later on, we shifted to line by line push broming scanning lot we do in IRS or resource sat. Similarly, we have some pixel by pixel optimism, optomechanical scanners, which we generally use in geostationary satellite. So we generally do three type scanning in the optical domain, not on the multispectral, this microwave. So these type of scanning will do is all depend upon your objective of that particular satellite. So if somebody asks you, then you can then polar line by line, wherein geometry pixel by pixel image has been taken. So when you're taking all this thing, and time is also going to be different. So time stamping also be done. Accordingly, we have to normalize the time. For example, to cover the from JNK to Kanyakumari, it will take near about to 7 to 8 minutes only for the polar satellite. So time stamping are very much important. But if you're coming from pole to pole, then the time stamping is very important. So that's why, in general, polar satellite in so concept of remote sensing is simple as you understand your eyes because you are making some measurement, some judgment from a distance without any physical contact of a particular thing. But this is a typical definition. But what is basically science behind this? That means in when we make any sensor, what will we do? We record the energy in the form of watt per meter square through our sensors for detectors. So every detector has its own obligation for particular wavelength. So sometimes we have a different type of filters to generate different wavelengths. So if you know electromagnetic radiation, because it is work on the principle of Faraday's, so energy moves in a speed of light. So when interact from coming from the sun, interact with the surface of the earth, it interact with the whole atmosphere, and coming back to the sensor from satellite, again it's interacting with the atmosphere. In atmosphere, we have aerosol, water vapor, ozone, and other gases. So according to the different type of scattering mechanism, because if you know Rayleigh scattering, when the wavelength is very big as compared to the particle, then is Rayleigh scattering happens. So you use that Rayleigh equations. Then me scattering, similarly other scattering also have to be answered. So that means when you get the data, you have to correct the data for all these things. So that means you have to solve the all atmospheric scattering problem. Okay, so our sun is giving the energy and we are capturing the reflected energy from the sun. So why this is happening? Basically, what is the background? So electromagnetic radiation is based on some spectra because light is coming in different type of wave bands. Okay, so it may be maybe absorbed, maybe transmitted, or radiated. Okay, so we have to make some spectrometer to get these all these things. So these are the spectra which can we get. So if you see this picture, then it is clear. So if you have UV or visible radiation, if interacting to a particular surface, what it will basically do? Because here we assume that because energy is in wave form also and particle form also, photon form also. So when it interact, it gives energy to the particular atom or you can say molecule. So atom in have an electron, neutron, and proton. So when UV and visible will play a game with this particular surface, it basically change the orbit of the electron. But electron have a tendency to go back to its original orbit. So in that process, some energy is released, which is going to be captured as a reflection. But infrared do not have a capacity to get these electrons out from its shell. So what will do? It will only twist. If you see on the right hand side, infrared. So twisting, because of twisting of the atom, it will generate some energy and that you can measure in the form of reflection. Similarly, microwave, which also have a very higher wavelength but low energy, it can only rotate. Similarly, radio waves and microwaves also. So according to the different wavelength, because wavelength UV have a maximum energy and this radio wave and microwave have less energy, they play some role in the atom molecules. And because of that changes, we do some twisting in the electronic and atoms, that energy has been going to be captured. So this is basically a physical phenomena happening when light interact to something. For example, you see the screen, so that electromagnetic radiation is playing a part. So now you can see if you have a UV and this visible, then different type of ground state can be changed for the electron. It go maybe to E1 also, E2 also, E3 also. According to that, using different type of equations, for example, de Broglie, or we can say Bohr's equations, we can generate how much energy it can give. So every wavelength and atom interaction is very unique. Okay. So that's why we will get different type of energy. This is all governed by the basic classical, or you can say physics. Then we have a vibrational energy will give different type of energy, what infrared is doing. Similarly, rotational energy given by the more sphere band, so it have a different type of energy. So that's why when we see the graph, you see the decay in the energy also with the function of wavelength. Now you can see only not only this within atom when vibration is happening. So not only vibration is happening, different type of vibration is also happening, because in IR and SWIR band. So symmetric stretching may be happen, asymmetric may happen, scissoring happen, rocking happen. So atom can or electron can move in a different type of direction also. Okay, according to the wavelength, and these decide that how much better interaction can be happen for a particular wavelength. So what I want to convey that every unique wavelength has a unique feature for a particular atom. That's why we'll get a very unique spectra of a particular surface. Now you can see the light from the sun, which I have shown you in the black. Okay. So, but in the outside atmosphere, it is coming little more, which I showcase you in the red in the left hand side part. But what we are getting on the earth is blue. So much of absorption is there. So if you see, water vapor absorption is there, carbon dioxide absorption is there, oxygen absorption is there in different wavelengths. So different wavelength have a different characteristic. I tell you, no. For example, in particular wavelength, if you see near to 1000, H2O is absorbed. Water vapor is absorbed, because in this wavelength they able to twist the water molecule, and they have get that absorption. And this remote sensing have a capability. If you see on the left hand side lower graph, that it can, on the basis of molecular structure, it can discriminate the water in three forms, whether in a vapor form is there, liquid form is there, or in a solid, in a ice form is there. So that's why I'm telling you the structural, atomic structure property is very important for the getting the EMR, electromagnetic radiation spectra. Okay, so when the surface changing, you are seeing the surface changing, but basically behind atomic structure is changing. So according to that, the wavelength performance is going to be changed. So you see what is happening in the you see the lower window, lower graph, where we are showcasing how much absorption is happening in different wavelength. So if you see, so much absorption is happening, and only white area in the lower graph showcasing that much is a window is clear. Okay. Similarly, if you go to upper, these are the bands where water vapor is playing the part, maximum absorption. Then carbon dioxide, then oxygen and ozone, then N2O. So it is clear that this is a basic information when you're planning to derive any sensor or planning to develop any sensor, what is needed for you, at what window you have to work, and which window you have to avoid. For example, in particular cases, for example, 3 to 6 or 8 nanometer micrometer, we do not develop any sensor for multispectral, because maximum is absorbing by the hydrogen, water vapor. So nothing will come, no picture will come. Similarly, we also avoid the CO2 bands. Similarly, we have to avoid the oxygen and ozone bands and N2O bands also. So this is a very critical information what we needed if we design a particular sensor. Okay, so what sensor is? Similarly, if I have put in the other way also, these are the absorption channel, and it is now clear the biggest absorption from 0.4 to onwards is the water vapor, and later on in carbon dioxide also. So when you're getting any data from the remote sensing, you have to do some atmospheric correction to remove, if even though you get a clear window, for example, I'm getting a 0.4 to 0.7, if you see in this particular graph, even though I have to clear it for water vapor, oxygen, CO2, okay. So now different type of sensor and wavelengths have different role. Okay, so optical has a range, for example, 0.4 to 2.5 micrometer. So it basically work on reflectance, means electron or atom will respond very fast. You just put the energy, it will reflect. But thermal will take time because it's work on emission and the Planck's law. Okay. Similarly, microwaves work on the backscatter and dielectric properties. Okay. Okay, so these are different things, because anyone, if you ask you that what is the difference between optical, thermal, and microwave, you convey that they give you different type of properties. One give you reflectance, another give you temperature, and third one give you the backscatter. And according to their properties, we use it for a different type of application also. Okay, so why we need space? Even though we develop the sensor, if we can develop the sensor for the Earth observation also. There is no need to go to space. The space is synoptic, give you synoptic coverage. So if I have put in a particular sensor at 100 meter, his coverage is on the ground is very limited because his field of view is very less. Similarly, if you put an aeroplane at a 10 kilometer also, the coverage is not going to be high and very limited, and energy and fuel consumption is very, very high. Wherein satellite, it is basically an economical practice. Once you launch it, you will get the data for multiple years for a bigger area. So that's why we put a sensor and we repeat, do such a way that whole globe observation comes. So this is the particular plot I have given you for a swath of 70 kilometer. That means when the sensor passes a particular point, it covers from left to right 70 kilometer data. Okay. Now you can see what I'm conveying you, that different type of spectral bands have give you different type of spectral properties, because the interaction with the particular wavelength have a different type of role for this atomic structure. So if you see in case of agriculture or vegetation, 0.4 to 0.7 particularly give you the information about leaf pigments. It's sensitive to the leaf pigments. Whereas if you go onwards, 7 onwards to 1, it will give you about the cell structure. And later on, it gives you about the leaf water content, or surface water content, and some molecular information like protein, lignin, and cellulose. So according to the wavelength, we can decide what our idea, whether we want to study chlorophyll, whether we want to study the leaf area index, whether we want to study the biochemical content like lignin and protein for cellulose. For example, if you want to get to know about the residue, then we have to use some higher bands. Okay, so this is the advantage of remote sensing, because everyone has this unique interaction with the unique molecule. Now, similarly, even if you go away ultraspectral, for example, photosynthesis is a function of many type of pigments. So if you have a ultraspectral sensing, you can segregate between chlorophyll A, chlorophyll B, carotenoids, xanthophyllene, and many things. So because they have a different type of absorptions. So this is the uniqueness. So now you can see, if the graph is clear to you, different feature I am showcasing: submerged water to floating to emerging microphytes, open water, soil to dry soil. Everyone has, because the molecule is changing, everyone has different type of spectra. So no one has a similar spectra. So that is the uniqueness of remote sensing. So in case, that means if we are taking different type of crops, for example, if you have a wheat crop, similarly we have it during that season, we have a gram. So both are going to have a different type of spectra. Now why this is happening? Because every wavelength has doing something to that particular plant. For example, I'm here showcasing few examples that at 430 nanometer, it give you it type with chlorophyll A, because it have a more energy, because wavelength is less, so it gives the electron transition is going to be happen. So if you see initial wavelength up to 660, electronic transition is going to be happen, and it's effective for chlorophyll and chlorophyll B. Whereas higher wavelength 910, because protein have its carbon and hydrogen bands, so because of touching in O-tone, you getting the signature of protein there. So I'm I'm not going to detail also, but different type of parameters having different type of wavelength, absorbing wavelength. And why they are absorbing, I have given the mechanism also. For example, protein, especially CH stretching is going to be happen at 730. So higher wavelengths will be very good for your cellulose, protein, and all. And why this is happening? Because their molecule is supporting these wavelengths. Similarly, later on also you can see many things are supporting sugar, starch, and all. So these are the sensitive things, but it's all depend upon the particular crop. For example, in gram, some wavelength will be effective, whereas in the case of residue of wheat or rice, some other wavelength will be effective because they are having more concentration and may have some different structure also of protein. Okay. So I have written a word protein. The protein are very different types, and starch is also very different types. So according to that, we get some variation in that particular wavelength according to the molecular structure. So similarly, in optical is a very different case because we are getting the reflection property, whereas in thermal infrared we are getting emission property. Emission is something like that when you're getting something. For example, I am speaking, you are absorbing something, but it will take some time to react. Similarly, we are getting the thermal bands from the sun, but it is absorbed after some time. Emission going to be happen. So that's why land surface temperature reaches maximum near about 1230 or 1, but air temperature is maximum near about 2 to 230. Okay, because of the decay. Emission may be little late. So for this also, if you want to do sensing, we have to get the window where we will have a more better signature, because here also the water vapor, CO2 and oxygen going to be a culprit for absorption. So at present we have different theories have come, different scientists have come up with 3 to 14 nanometers good enough for thermal. But basically 3 to 6 is only used for water vapor absorption band, whereas 7 to 14 micrometer is good for only for thermal. And thermal works on the Planck's law. And Planck is the scientist who have given that how with the change in the wavelength, absorption and spectral radiance going to be changed. So I will show you. Now you can see on the right hand side graph how that with the change in the wavelength, the temperature is changing. So that graph is given by the Planck. Okay. Similarly, here the concept of black body also comes. So black body is the body which absorb all energy and can able to emit all energy also. That is called a perfect black body. So at present, sun is a perfect black body. So here with the Planck's law, this equation, what we have written is a big way. Basically, it works only for the thermal region. But if you go to the microwave region, then it changes to Rayleigh Jeans equations. Okay, so there we have it not going to be have it this type of curve, the like parabolic. So as the temperature going up, the wavelength going down. Okay. Similarly, if you go to this side, the here also Stephen Boltzmann law is also we can apply to get how much energy we are getting. For example, we have LST of land surface temperature in Jaisalmer, whereas in land surface temperature in any Indo-Gangetic plain, then the land surface temperature is very different. So according to the emissivity, the M energy, what we are getting from the particular surface is going to be changed. And change can be detected on the basis of wavelength. So at present, what we have conveyed that 7 to 14, we are able to capture the Earth thermal dynamics. Okay. But what is difficulty in the thermal remote sensing is that because if you have taken thermal temperature through the gun also, it also showing lot of variation. Why? Because the surface is always be brushed up by the wind. Similarly, when the satellite is taking picture and some horizontal wind is going to be happen, the surface temperature is going to be changed. So, a lot of research from the French scientists, Indian scientists, and US scientists, they have come up that up to the 50 to 60 meter, that horizontal wind velocity, or you can say advection, can be minimized. So, our latest satellite, which is going to only come for evapotranspiration, it is a big project between ISRO and France, which name is Trishna, is giving you thermal information at 50 meter. So at present, no one have that capability. So that going to be launched most probably in the initial months of 2028. Another remote sensing part is active passive remote sensing. Is microwave. So passive means when we're getting this energy from another source and capturing from our sensor. But active means when we are giving energy also to the particular target and getting the energy and recorded it. So active remote sensing basically used in the microwave and lidar also. Lidar is in the optical domain, and sonar also, the sound waves also. But we talk about the microwave only. Okay, so microwave is a very important part because it have a capability to overcome the problem of cloud, because its wavelength is high. So if the wavelength is high and water molecule are diameter is less, it can go out from that molecule and able to capture the signal of the surface. So radar technology is very important. That's why nobody in within one country to another country, nobody transfer this technology. Okay. So primary advantage of radar remote sensing is we have active sensor. So in day and night cloud, we can get the data, and it also provide you different angle data. So you can get the surface property in different way also, different angle also, and different wavelength also. Because if you have, for example, an NISR, what Dr. Navanshu is conveying you, it have a 12 frequency, L and S. So it give you, L have a more penetrating power, S have a surface envelope, so you will get better information. And if somebody asks you, you have to the takeaway message is that you have to convey that micro remote sensing work on surface roughness. Roughness means how much height of the surface is there, dielectric properties, how much moisture is there, and moisture content is there. Okay, so these three are the important property of a surface which going to be affect the signal of active microwave. Okay. So in active microwave or in passive microwave, polarization is the important part. What is polarization? If you see on the left corner, you see the VV. VV means vertical to vertical. When the waves are going from the sensor in a vertical way, target the earth, coming back to the antenna and captured in the V form. So that is called vertical polarization. HH polarization go in a horizontal way. Sometimes we go for a quad pole also. Quad pole means giving the energy in V, but absorbing the energy by the sensor at H or antenna. And in this case, because if you see why we call synthetic aperture radar. In radar, we always use synthetic aperture radar because one sensor giving you energy for a point A, while moving from the nadir of a point A, till now it can see the point A, it always gives pulses to point A and get the energy. So that's why you will get the number of data for a particular point at different type of distance. Okay. So when we take the energy, because we are moving also, platform is moving, then the platform is moving, that is called azimuth direction. Whereas taking the energy from different pulses in angle called as a range, ground range. So two important points are there from this macro remote sensing is angle, ground ranging, and azimuth. So range resolution is a function of your pulse duration. If you given a pulse and captured by your antenna, what is the duration? Because basically electromagnetic radiation work at the speed of light. So resolution is depending upon C into speed of light multiplied by pulse duration divided by 2. Whereas azimuth resolution is a function of your antenna length, basically a diameter, and the distance between the antenna and the object. So in that manner, you can compute both these resolution also. So whereas in optical, we are getting only ground resolution. Here from the ground, we are getting two resolution. And then you have to make one. So that need processing. And you can see on the corner of the right hand side, I have given you the wavelength. P band 65 centimeters. So it's have a more, if you make up any amplitude of 65 centimeters, so that means it have a penetrating power of more. It can even penetrate up to the surface, even the sugar cane is there. Similarly, L band has 23 centimeter wavelength I am taking you, and S band 10 centimeters, C band 5. So if you convert into the frequency, the L band is near about 2 gigahertz, and S band is going to be 5. and C band is also 5.5, 5.6 gigahertz. So when the microwave signal interact with the surface, so it have a different type of functions according to the surface. So if you see on the right hand side, I am showcasing only three type of surface. One is very smooth, like mirror, the water, and very stable water. So all backscatter is coming and going in the other direction. Okay, so nothing will be captured by the antenna. Where when we have some roughness, so if you see many things are going, many energy is coming on from the one direction but going in a different direction, but intensity is very very different. Okay, so according to that you will get different type of intensity. But if the surface is very rough, so you will get a very diffuse type of spectra, means backscatter. So similarly, if you see on the right hand side, I have just showcasing that the power of penetration from X band to C band to L band, how the penetration power is going to be increased. If you see in the dry snow, the lower graph, you can see from this X band, you can see only the surface property, whereas C band touches the surface, where L band can penetrate the surface. Okay, but this also a function of angle. So in microwave, you have to take care that according to the frequency and angle, you will get the information. So angle is also very important. If you have a 35-degree, a 45-degree, a 60-degree, it is giving you different type of information. For agriculture purpose, 30 to 45-degree is preferable wavelength. Sorry, preferable angle. Now you can see different signature of microwave in the C band from different type of surface. For example, if you see rice is given, I have given you in the green, whereas other surface, water in blue, urban as I have given you in a way, shaded form, homestead in red, and other crops. So if you see water will be taking as a mirror. So all energy go out. So that's the backscatter is minus 20. Or in other frequency is maybe minus 15, and other frequency is minus 25 also. But in the rice, you see number one picture is a pre-transplantation. Second is transplantation. So on number two, you see the backscatter at number one is between minus 5 to minus 10. But once the transplantation is happened and water is applied, is come down. And similarly, once the tailoring is happening, is going to be up. The change in the backscatter will give you the information of the rice transplanting and its behavior. So any type of flooded rice can be well captured by the SAR. And why we prefer this SAR? Because in India, maximum rise is going to be happen in Kharif. So that monitoring can be done using the microwave data. So now people are using C band and S band for monitoring of rice. So this is all about remote sensing. Now I'm changing gear towards what we are using this remote sensing in this our space application center. So we are working on different type of themes. Some are production centric, some are farmer centric, and farmer income centric, trade, and climate change. So why we do all these things? Because as per the demand from the ministries of agriculture and farmer welfares, state departments, NDDB, AMOL, ICR, NGOs, and IMD also. So at present, we have different type of short and long-term goals. What we are doing, I'm just showcasing some of the examples here. So first, our main aim is that we have to do inventory of field crops. So what ministry want, that they want multiple forecasts in a particular growing season. So we are doing this, and we are whatever the technique we develop, we transfer this technology to ministry, and its center is MNCFC, Mahanovalis National Crop Forecast Center in New Delhi, in the IRI Pusa campus. So in previously we are doing the sample segment approach. So where we are doing different segment A, B, C in a particular area. A is very high homogeneous area, B is little fragmented, C is highly fragmented area, and do some ground sampling. On the basis of doing, we do some classification using typical methods like maximum likelihood. And now we are switching towards machine learning and giving the complete enumeration in one time. So now we are giving the complete enumeration using our resource set 2 and Sentinel-2 data. Sentinel-2 is providing 10 meter. Resource set 2 AWS is providing 56 meter from AWS, and list 3 is providing 23 meter, and list 4 is providing 5 meter data. So at we are giving near about 25 crops output to the MNCFC. So MNCFC working on this and providing opportunity to the ministry. But not only with the optical, we need also kharif crop. So I have already conveyed that how we can do for this particular rice. But we can able to check different type of other crops like maize and bajra also, because doing the ground sampling, for example, I'm showcasing the example of Agra and Nasik, we have segregated the bajra, maize and paddy because all having different backscatter in different polarization. So here we are using the different polarization, means we're giving the energy in vertical wave, getting back in horizontal wave, giving the energy vertical wave, getting the energy again in vertical wave. We having more penetration power, whereas cross pole VH have a less penetration power. Within polarization also penetration power will differ. Okay. According to that, we can generate the backscatter, and on the basis of the backscatter, we can use the traditional methods as well as the machine learning method like random forest or conical forest to generate the classified image. Similarly, from this different type of frequency like C band, give you better surface information and we give you more deeper information, we can get the crop tall information also. So when we have a very tall crops like sugarcane or jute, we can use the L band very effectively, whereas as compared to the C band, because C band penetration is less. So these band, when we check up with the C and L, both the accuracy will increase. So what I'm showcasing is that when you use only C band or when using only L band, because C band affecting for the shorter crops, L band is affecting for a tall crop. But if you use the fusion of C and L, the accuracy of classification is going to be increased. So on the basis of different type of radar data, especially for ARISAT 1A, we have developed one software which have put at the Bhunidhi, in which you provide the EOS 04, means ARISAT 1A data, and some ground truth data for your own region, and you can use this tool to generate the classified image. So in which what we have done, we have applied multiple machine learning models and done the ensemble of machine learning to generate the classified map, and is showcasing the accuracy between 85 to 90% for the regions like Bengal, Odisha, Gujarat, and UP. Similarly, we can also do the classification of horticulture crops. But horticulture crops and change in agriculture crops is very different, because agriculture crop is very dynamic. Whereas horticulture like mango, citrus, banana are more stable. Right? Go in a temporal domain, their duration is very high. So in this case, we can use list 4 data, because list 4 data provide you 5 meter data at multi-sector data, and Cartosat. Cartosat provide you less than meter data, but in a pan. Pan band telling you this only one band. So using the combination of this, we can figure out the different type of orchards also. And when you use these fusion of these two data like list 4 and Carto, we can able to even count the trees also. Okay. So these are the things. I'm not giving you the example which I have showcasing on the left hand side, lower side, where ARISAT when also can be used. This microwave data can be used, and it gives you little early detection as compared to the this multispectral for a banana. When the banana is only having lower height, it can able to detect. That is the beauty of microwave, because microwave is depending upon the volume scattering. So as the volume is going to be changed, you're able to capture the better signal. And banana is a fast growing crop, so within 1 month its volume is going to be changed a lot. So that's why you're able to capture this particular image in the microwave. Similarly, when you want to describe a crop at a very, very high resolution, like 5 meter or 3 meter, then multispectral unable to give you that answer. So in that case, hyperspectral sensor is the need. Why hyperspectral sensor? If you see on the left hand side, different curves of different crop like wheat, coriander, chickpea, methi, mustard, wheat, peas, and bare soil, having different type of profiles. So these profiles give you that all crops have a different type of biochemistry. So that you have to capture. Then using this biochemistry and hyperspectral data, you can classify in a more and more better way. So scale here is a field scale. Okay, so 5 meter classification you can done, and you can discriminate in quota. You can discriminate. You can see the accuracy is 86%, and everything can be discriminated. Okay, but what is the difference between multispectral and hyperspectral? Multispectral, we have a some discrete type of bands. For example, we have in Avis 0.622 to 0.68 for red band. Green we have 0.522 to 0.58 or 59 micrometer. Similarly, NIR 0.77 to 0.86, and SWID is nearby 1.66 to 1.77. But they are discrete. But in this hyperspectral is continuous hyperspectral at 3 or 5 nanometer spectral bandwidth. So it's a continuous information from 400 to 2500. And if you see in the left hand side top some gap. So these gap is happening because of the absorption of water vapor, high absorption of water vapor, that we have to neglect these bands. Otherwise, maximum information we'll get about the plant chemistry. So if somebody asks you what is different, the multispectral give you about the canopy and all information, whereas hyperspectral give you the biochemistry of the plant. So you can even discriminate the crop varieties also. So on the left, right hand side, lower side, I am showcasing different type of mango varieties you can segregate. So that is the beauty of hyperspectral. So in future, people are working on at present. This European Space Agency launch in MAP hyperspectral, and Italy has launched Prisma. So at present, two big hyperspectral mission is going on. But in future, in few years back, ISRO also launched HISIS spectral. But basically, that is not for the civilian purpose. It is used for the defense purpose. And similarly, after getting the crop map, what our aim is to get the crop yield. So different type of approaches we are using, like force model, or crop simulation model, semi-physical model, agrometeorological models also, and sometimes spectral model also. So different have a different type of advantage and disadvantage. In crop simulation model, if you want to run a model, you need a lot of genetic coefficient, so it's difficult to run on a bigger area. So you have to sacrifice the genetic coefficient at the pixel level. Whereas in efficiency-based model, which will get more and more remote sensing data, and it will give you the full crop growth data from the remote sensing. So now it is more prevalent approach. This efficiency-based approach will give you a better result. Even though some people are using rainfall and AT base, which you get from the satellite to generate the crop yield. So it all depend upon how much data you will get, which crop you want to address. So this is the combination you have to use to get the different type of approaches also. So at present, Government of India is pushing two approaches. One is simulation, one is efficiency-based approach, but simulation only for validation purpose for a limited area. Now I'll talk about agromet products and its services. So if you get lot of data, because agrometeorology is also driven by weather, and weather is very dynamic. So what we will do, we have to switch over from polar to geostationary satellite. So we have number of geostationary satellite. Like at present, we are working our 3DR, insert 3DR and 3DS. They are providing you surface insolation every half hourly, clear net radiation, land surface temperature, surface albedo, potential evapotranspiration, and actual evapotranspiration. That is available at MOSDEP portal also. And also we have given all these algorithms to Indian Meteorological Department, New Delhi also. So they are using for different purpose. And we also providing you this soil moisture. So as Dr. Amanshu is conveying you, the NISR is providing you 100 meter soil moisture. This is the SMAP soil moisture. It is in some kilometers data. But at present, we are going to provide you 100 meters data. But when you say 100 meter, but problem is that in the NISR, is temporal domain is poor. So every 12 to 17 days only will get the 10 meter data, 100 meter. So now we are focusing that can we use multiple satellite to get a soil moisture every week using this approach. So you see that in a particular time domain on January 4, how much data we are getting from the soil moisture, and it is giving you a realistic picture in different part of India how the soil moisture is varying. And we also provide you global NDVI. NDVI is a vegetation index, but basically it is a surrogate for green vegetation vigor. So around the globe, has been used for multiple purposes to get the health of a crop. Anomaly can be used to assess the stress of the crop also. So we have one sensor called OCM, Ocean Color Monitor. 3, it will provide you global mosaic within 3 to 4 days, the global NDVI also. So you will get to know in which particular part of the globe NDVI increasing or decreasing and where the stress is more or less. So what we will do after we have a lot of discussion with IMD for near about 7 to 8 years, then later on we have zero down that we can use this product for the agromet advisories also. So with the lot of discussion with the IMD scientists New Delhi and Pune, we have zero down few products like insect generated PET, insect generated aridity index, land surface temperature, NDVI, and soil moisture can be used for this. And initially we have taken 6 agromet field units to give them bi-weekly data in the Excel format at district and block level. So at present, we are providing them, and 2 and 3 AFMUs are working very hard to use this data along with the weather forecast to generate the advisory for the area. So one unit is Parbhani, which they are using very rigorously from last 5-6 years. So one independent team had done the survey. I have put the paper also, which published recently in Current Science. They're showcasing that even though the production-wise, not much difference is coming between the person who is using the satellite-based advisory and the normal advisory, but the cultivation-wise, cost of cultivation is going to be decreased. The person who is going to use the satellite-based agro-advisory along with the weather forecast. So it decreased near about 5 to 8% for soybean and cotton crop. So that shows the effectiveness of the crop because PET can be very much used for the irrigation planning. Similarly, NDVI variation from block to block convey you where the crop is good in a good health, where the crop needs some attention. Similarly, in agrometeorology, the important part is drought. So how you can address drought? In agriculture, basically we see 3 types of drought: early, mid-season, and late season. And now what Dr. Namanshu sir is conveying, the flash drought. The flash drought is an extreme event of a high temperature when high evapotranspiration is going to be happen in a very less time, but affect a very large area. So at least, for example, you will get exposed to a cold, get a very high fever for a few hours, but your health is deteriorated. So you understand what is flash flood. But in the traditional way, we have early, mid, and late season drought, which is going to be happen with the change in the crop growth season. Okay, so that means we need different type of indicators to address early, mid, and late season droughts. So initially what we have done, we use the soil moisture and NDVI to assess that how we get how much area has been sown in the particular area or not. So that's why that can be used. Similarly, reference ET can also be used for this drought monitoring. I will showcasing you how we'll do. So here you can see we use the rainfall from the satellite and evapotranspiration from the satellite and generated this dryness index, how the dryness index is going to be changed from year to year. And you get to know where area where less rainfall is happening, evaporation is more, need more attention. So these particular type of index can be helpful in the rainfall region. Similarly, we have generated the this evapotranspiration for multiple years to assess that where the water demand is growing in India when the water demand is shrinking in India. So we have find out the maximum water is going to be consumed in India in the form of agriculture only. And we have also quantified Kharif what is the demand and what is the Rabi what is the demand, and which region has more shown the more vulnerability for the water usage. And skip this. Now we have developed using the rainfall from the satellite on NDVI, because when rainfall happen, it cannot directly affect the vegetation vigor or greenness of the crop. It takes some time. So using the lag response relationship between rainfall and NDVI, we have developed the new combined index. So in this, we can use this for late season drought monitoring. So this is very helpful, and in arid region or semi-arid region, it provides you very good result where the drought is happen. So you can use this type of information. Paper is published, so and data is now free from Google Earth Engine also to assess the response of drought in your region. I'm not going to detail all this. So I'm just coming up the drought portal. So we have developed and the demand of Ministry of Agriculture using all type of satellite data from polar satellite to GSA satellite data. We are generating the mandatory indicators and impact indicators. So mandatory indicators we are generating two ways, using IMD's own rainfall data as well as satellite rainfall data also, and showcasing the correlation of 0.95 to 0.96 only. The correlation is very high between the IMD rainfall and new product what we have developed for rainfall is called a GS Map Merge, which is available at Mosaic portal free of cost. Anyone can use. It is available at 3 hourly data. So you can use the data, and so generate the mandatory. We have generated the cumulative rainfall, rainfall deviation, dry spells. Similarly, we have generated the impact indicators, like we have generated impact indicators like NDVI, VCI, LSWI. So different type of things we have developed as per the norms of the drought portal published by the Government of India 2020. So we have translated that manual in the using the satellite data. And now this portal is a part of Krishi DSS, which is the umbrella program of Ministry of Agriculture. So if you see on the just see on the right hand side top, we have compared the IMD rainfall with the satellite rainfall. It matches very well. Okay. So you can visit this drought portal and give your own comments also how we can improve further. And we have seen when the drought is giving information how the different type of drought is published, that where the problem is coming, for example, in Karnataka and Bihar. So we have seen in that. So from the ground level, person to ministry secretary can see that where the what is the situation is there. So this is very helpful to find out where the drought is there, where the ground team have to visit, because finally drought declaration is the state subject, and central team along with the this state team have to visit few places to find out the intensity of drought. So this portal is very helping in this regard. Now I'm just coming to the later part, the crop stress management, precision agriculture, because this is the most important part. Because when the crop is disease and pest is going to be happen, lot of losses is going to be occur. So because disease and pest is a function of your crop phenology. So first we on the right hand side we have developed the methodology to generate the crop phenology using the regular data from the multispectral satellites. So using this data and along with other data, we can generate different type of phenology when the crop is sown, when tailoring is going to be happen, and different vegetative stage going to be happen. On the basis of these and long-term ground data of particular pests in the particular area, first we have developed a model using ground-based meteorology and phenological data, then translated these to using the with forecasted data and remote sensing data to generate the grid scale for warning model for particular pests. So at present we have developed this mustard aphid forecast model, and we have this transferred to some private company also, and they have provided given some money also for this particular work. And in future we are working on many other pests also, and many people, even now private companies, show the interest that they want this type of models for their work. Similarly, we are also working on spectral characterization of disease and pests, how they are different from healthy and infested plant. So different type of crops, different type of pests have a different type of signature and different bands, because different type of pests affecting different biochemistry of the plant. So that's why different type of bands in coming. So using these band configuration, we can generate the different type of indices, and these can be translated on the using the multispectral data. And these particular data set, or you can say library of this particular data set, can be helpful in future for designing that particular multispectral sensor for particular pest and disease also. Similarly, we can use the different type of health indicators like leaf area index, chlorophyll content, water content from the particular vegetation index, and generate that where the stress is happening, where the moderate stress is happening, where the healthiest crop is there. So we can precisely use the information and get to know where the particular field need attention or need better management. So we are working on this, and similarly you can see we have a ability, because everything, so you can see in the previous graph on the right hand side, every chlorophyll and leaf area, water content, leaf area have a different type of unique bands for their estimation. So on similarly, we can also retrieve different type of pigments also using hyperspectral data like carotenoids and anthocyanin, which might be very helpful for the photosynthesis assessment. So these things can be done using remote sensing. Similarly, if you are getting only multispectral data at a very high resolution, for example from UAV, okay, so what you will do, you will get within a particular. So this is a rice station where we have a UAV flight of multispectral. Then you can see on the UAV side, I am showcasing through this that how much within a plot, how much variation is coming. So, and when you plot SD, the SD within a plot is very high. But when you retrieve this same parameter using 10 meter sentinel to satellite data, that variability has been reduced. Similarly, if you use 10 meter satellite data along with 20 meter more data, the variability has been enhanced because we have included more bands here. Okay. So variability is a function of two things: spatial resolution as well as spectral resolution. Similarly, we have a capability to using remote sensing data and eddy covariance data, that we can generate different energy balance models to get to know about the surface evapotranspiration. So these things are we are going to use in Trishna mission. So basically in Trishna we will get every 3-day evapotranspiration. So we will get to know about the what is the water usage and what is the efficiency of a particular crop. So here we are using surface energy balance model, which is basically theme is net addition is a function of latent heat, sensible and ground heat flux. And using the different parameterization of resistance for surface as well as the aerodynamic resistance, we can do the modeling for the particular work. And we are also working on that how we can segregate this evapotranspiration into transpiration into and evaporation also. And this is the way we can do. For example, I'm just showcasing one example using UAV based thermal imaging and optical imaging to generate the evapotranspiration. So you can see on the right hand side few pictures where the latent heat we are providing and canopy transpiration is also provided. So that heterogeneity you are able to capture, because everywhere the temperature is different. As the temperature is going to be different, the evapotranspiration is going to be changed. Similarly, using the hyperspectral data, we can generate the canopy nitrogen and soil salinity also, because these are given by some peculiar bands. So these bands can be used to derive all information. So, but this is hyperspectral data, not ordinary multispectral. Similarly, we can distinguish between biotic and abiotic stress also using this hyperspectral data. And also, if you get very ultraspectra, from hyperspectral to ultraspectra, hyperspectral bandwidth is 3 to 5 nanometer, whereas ultraspectral bandwidth is zero point 0.1 nanometer. So then we can able to retrieve the fluorescence signal also. The fluorescence means the energy which is reserved after this photosynthesis and chemical quenching. So that energy, if we get to know, we can able to assess the photosynthetic capacity of a particular plant. So that will directly give you help to early detection of any stress. So nothing can be better than early detection of photosynthesis. So that, because once the some even the biotic abiotic stress is going to be happen in the plant, basically first exchange is going to be captured in the photosynthesis. So if you get the photosynthesis variation, we'll get to know that whether the plant is going for any type of stress or not. And using this SAR data and using some methane fluxes data, we can generate the plot scale, a field scale, methane fluxes, yeah, methane emission also. So we can generate every phenol phase by some coefficients using methane flux data, and generating the phenology using the SAR data, which I showcase you. On that basis, we can generate the methane flux, how much emission is going to be happen. So we have done in pre-COVID and COVID also. In pre-COVID and COVID time, we have seen lot of change in methane flux. And some people say because of atmosphere, there is not much change in the atmosphere temperature, everything is going to be changed, not changed. We have seen the maximum changes happening because of in COVID time they had not applied much organic matter in the field, so that changed the dynamics and less methane has been emitted during the COVID time. Similarly, using the SAR data, we can assess the crop mapping also, how much crop is damage, due to the cyclone. So cyclone, because why use the SAR? Sometimes we use optical also. So we can use a combination also. But in initial phase, when the cloud is also persist, the SAR will give you the better watches, total damage is there. So any type of changes going to be happen after cyclone. Initially, result we can do SAR, but later on when the cloud is clear, we use Opti and SAR. This is what is the total damages happen because of this cyclone. Similarly, we can do the damage assessment because of hail, storm, or flood also. So this is my ending slide. At present, what we are working here, block to district scale, crop assessment and early assessment, where we are main focusing on development of new agromat products for agriculture drought using INSET 3Ds, GISAT, which are coming satellite, and fourth generation set, which are also having some hyperspectral information, and Trishna. Similarly, we are also working on village scale crop insurance and agro advisories, where we are using optical, C-band, and microwave data also, and farm scale stress detection is the now the need of the hour. So disease phenotyping, crop photosynthesis, using hyperspectral and SIF models, crop water footprinting, crop water productivity, and later on for horticulture crop is a big gap, because at present we do not able to address any horticulture crop yield. So we are exploring now how we can use the LIDAR. So in this direction, we have purchased one big LIDAR, UAV base, and to assess that using the crop height information, can we get some information regarding the horticulture crops and crop yield. And so, we are also working on this surface soil chemistry, which I have not showcasing you, only this salinity part I was showcasing, where we are also working on this carbon part also, organic carbon part also. And similarly, heavy metal detection, for example, in Bengal, arsenic is a main issue in some part, whether we are able to detect or not using hyperspectral data. So these work we are doing. So if anyone can want to join our in research, can join here. And thank you. So new field for anyone who interested is microgravity experiment, because India is planning to send some human flights soon. So microgravity, how agriculture is providing it, happening in agriculture in microgravity, and radiation experiment is also we are doing similarly. But for agrometeorology, we have some eddy covariance and getting the data to characterize the energy balance and surface property of a particular area. Thank you. Thank you, sir. Yes. Hmm. 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 Oh, fine. Hmm. Hmm. Fine. Sure. Sure. Okay. Fine. Hmm. Yes. Hmm. Sure, sure, sure. Sir, first is regarding CPL band. So this is a microwave. So microwave is working on higher, very very higher frequency. So frequency is high. So wavelength is less. Sorry, frequency is low. So wavelength is very very high. So that's why I'm showcasing you that L band is near about 26 centimeter and C band is some centimeter. So they are working on different gigahertz. So microwave only advantage is that it can penetrate the cloud. It give you even night. Multispectral optical sensing cannot work in night. Microwave can work in night also. Radar can work on night also. It will give you the same information what is giving you in the sunrise or during sun. Same information it will give you. So that's why different frequency, C band penetration up to surface and few centimeters. L band even penetrate up if the bare soil is there, it can go up to 10 to 12 centimeter, sometimes 15 centimeter also according to the bulk density and particle density of the soil. Similarly, if you have P band, it can even more penetrate more. So these frequencies depending on their penetration power. So sometimes P band people will use, defense people will use to assess the query of what is happening behind the forest area. Okay. So that is the first query. That's what is CPL bands. It basically in micro remote sensing it has been used. Now regarding list 4 and list 3, because in India when we have do the development and around the world, we first focus on C band in microwave and optical remote sensing multispectral in the optical domain. So LIST means linear imaging self-scanning system is a passive remote sensing where optical data, sun is reflected data has been captured in 4 bands, which is green, red, NIR, and SWIL. Whereas in list 4, list 3 is providing you data in 23 meters every 20-25 days. But whereas list 4 data will give you at 5 meter. It is basically provide you data in 3 band, green, red, and NIR every 45 days, sometimes 70 days also. So now regarding data, now at present ISRO has made free of cost data up to the 5 meter. So anyone who can register himself in Bhunidhi can download the data. One aspect is clear. Another regarding MOSDAQ data. MOSDAQ data basically is meteorologic oceanographic data archival system in which anyone who want to download the data first have to register itself through MOSDAQ and can download any type of data, meteorological data from INSET, from OCM, any type of data they can download, even download the products also. Similarly, it's like MODIS. So you can use different type of data sets also. And now difference between multispectral and hyperspectral, ultraspectral. For example, I'm showcasing you that we are having wavelength from 400 to 2500 nanometer in optical domain. So if we going to be have a spectral band in a discrete manner, for example, I have a band from zero point 0.6 to zero point 0.7, then I have a band from 1.1 to 1.2, in between no band. So these discrete band will we only have having 5 or 6 band in a discrete manner in this wavelength region, then we call it is as a multispectral, which having a broader bandwidth. For example, in red band, in list 3 or list 4, having a bandwidth of 0.62 to 0.68. So if you means 620 nanometer to 680 nanometer, so 60 nanometer bandwidth. Whereas hyperspectral bandwidth is 3 to 5 nanometer, and it's a contiguous bandwidth bands. There's no discretion, no loss of data in that. So the band has been designed such a way every band information will get at 3 to 5 nanometer. Whereas ultraspectral, it is the bandwidth where we are getting nanometer is multispectral is 60 90 nanometer bandwidth. In in ultraspectral bandwidth is 1 nanometer. So that means your detector should be very, very strong to get to know all these things. So that's why this data will provide you use for fluorescence. So European Space Agency is going to launch one mission soon. The name is Flex, Flex. Flex mission you can read on the internet. So that mission going to be have provide you solar induced fluorescence, and they are using this ultraspectral sensing. Ultraspectral sensing also used for many other sensors like tropomi, SOMI, and Sentinel-5, where they are deriving the carbon dioxide, methane of an atmospheric profile. So they are also using very high sophisticated spectrometer. They are using the ultra sensing. Okay. Now regarding, I have conveyed that how we coordinate with SAC. So for Indian student, we have, if you attach with any university, we have SRTD program. You can visit our site, Special Application Center site. We have SRTD program. So through that you can be entered as an intern and work with us. Whereas an international student, we have a CSTAP program, United Nations program on CSTAP. So you can use our site and get to know all information. So do you have to do all this thing? So every year, 1 year we have a remote sensing based CSTP program from United Nations side. Another we have United Nations side CSTP program on satellite meteorology, where we also covered agrometeorology also. So maximum students come from Philippines, Mongolia, Bangladesh, Nepal, Sri Lanka used to come in CSTP program. Now you can get the data from MOSDAQ also, and we have other portal that Vedas Sac ISRO. So Vedas Sac ISRO will get you the blindly will get the data that how, for example, over Indian region, what is the performance at present in your region. So all latest satellite data we provide, but you cannot download data, but you can download the graphs and all everything from there. So you visit this Vedas Sac ISRO portal also, and in this we also providing you the drought portal also we have put it there, so that you can use. Another example question is regarding evapotranspiration. See, evapotranspiration, what two algorithms we have adopted in Trishna from the between ISRO and France. Both are working on this surface energy balance model only. One we are using the this contextual plot between albedo and LST, and then generating the evapotranspiration. Another we are using the physical model based on stick model. So all papers we are available. So we in the stick we are generating 4 equations and simultaneously solving 4 equations to get to know about the evapotranspiration or evaporative fraction also. Now regarding the last question regarding data quality, so all data is free now. So whether you use our Indian data for you can get from this Bhumidhi, and also for international data like Sentinel, Modis, Landsat, and their products, along with the weather data, along with your model data available at Google Earth Engine. So you simply write one script, and online only you can process the data and download the final output. So there is no need for data download also in Google Earth Engine. So that is a big advantage. You want to learn remote sensing. For example, you in your place there is flood, and you want to know how much flood damage has happened. You go to Google Earth Engine, or you go to ISRO site, download the ARISAT 1A data, or there you can use Sentinel 1A data, because that will provide you C-band data. Use the previous image and current image. See the change in the backscatter. If the backscatter previously is low, in minus is low, for example, -5, -6, and now it is going to be -25, -36 in the flooded area, you will get to know which area has been flooded. And because its temporality is 5 days, so you will give every 5 days you can update which area the flood is shrinking and which area flood is persistent also. So in that manner, Google Earth Engine directly you can use it. Okay. Sir, any more questions? The all in the case of Google Earth Engine, all quality is very good, very well georeferenced, very well radiometric corrected. Similarly, in that particular case of Bhunadi also, ARISAT 1A and shows that data is very much geometric and radiometric corrected, so you can directly download the data and use it. But in Bhumidi, the issue is that you have to download the data. So data is very huge, some GBs. It takes time, then you process it. In Google Earth Engine, it directly you go in Google Earth Engine, write a code using that particular satellite, you can process it and get the result. So that is the difference. And in Mosaic also, for example, you can download the Mosaic PT product also for India every day. So for example, every night at 12, they use a daily data, daily PT. So every night at 12 they process the PT. So morning you can get the potential of transmission over Indian landmass and nearby area. For example, towards Pakistan, Afghanistan, Sri Lanka, Bangladesh, you will get the potential of transmission. So on the basis of that, if you collect the data from multiple days, you will get to know the profile, and on the basis of that, you can plan the irrigation scheduling in your area. Hmm. 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 Yes. Sir, I'm just showcasing. I'm again sharing my screen. So showcase you something. Whether these people will get it in a better way. So, you go to our Vedas site. I think you're able to see, no? So you go to this site, an application, for example, you go to vegetation and crop monitoring. Also, we have a Krishi JSS portal also, air quality, urban snow. So if you go to vegetation monitoring, so you will get a number of satellite data on a regular basis. So, for example, I here you if you add Sentinel, it will take time because Sentinel is 10-meter data. Okay, so now you will get this type of data here. So this much coverage for a Sentinel-2, yes. So this is the data of 8 April 2026. That is the coverage in India. So I am changing the layer. For example, soil moisture is also there, rainfall, temperature, everything is there. So I am taking towards modest 250-meter because 250-meter will be downloaded fast. So if you go there, no, they can use no directly. For this there is no registration is also needed. No. No, at present, many government organization, this Gujarat government, all are using. No, they are all using. So that is not a big deal. They are all using, but this data you will get from little lag because Modis it will give you on through some lag. I think, for example, I don't know why it is not. Hmm. Hmm. And if you click, you will get the graph also. Okay, I'm just seeing some issue. Why it's not coming? Where Modis? Yes. Now you see, for example, I have click here in this part of India. Okay, so the profile will come for the whole multiple years because I have put for the year over year profile. It will come. Okay, I think Bhutan is covered. Bhutan, I think, is covered. Bhutan, Nepal, I think, is covered. I'm showcase you. It is taking time because maybe server is busy. Server is might be busy, but it will give you, and you can download this graph also. So that is not a big deal. I'm telling you. You see, you see this much of area is covered. So Bhutan, Nepal, Bangladesh, Burma, part of Pakistan, even this area is also covered. So if I put in some part in and in this we also have provided you that I just want to show the graph. So every graph will come. You just put a lat long on the right hand side. There is a lat long point is also there. So you will get the lat long here. You can go and put the lat long here. Okay. So find location you can put and you get that location. Put the lat long and get the data. But here you cannot download the image. That is the issue. Okay. So it will take time. Otherwise, the beautiful graph used to come. Okay, so you can visit. Sir, just a minute. Just a minute. I'm just showcasing one Dout portal also. So you can enter the Dout portal. For example, MD rain it is giving you. So you select the time. For example, March to May 2025-26. What is the condition on 8th April 2026 over India? So 44 large deficit, 94 85 normal, 136 excess. So 340 has a large excess. So this much information will get. You change the date, season. For example, I'm keep a season, this, and get the you will get the different type of values. Okay. So now Flashed out. We are working because this is in India very not very regular phenomenon. It's a very rare phenomenon. So at present we are working on it, and evapotranspiration and LST going to play a part in that. Okay, sir. Thank you, sir. Thank you, sir. Thank you for inviting me. Yes, sir. Sure.